Welcome. So, this video we will continue our subject on visualization, and two specific topics I will be talking about conceptual diagrams. And conceptual diagrams, these are generally very useful and handy for explaining, for example, your method. Like if you have like a, a, a complex method that has many steps and you just like yeah, I mean, you describe it in writing, but like a conceptual diagram, it helps the reader to really better understand your method and connect the dots, see how like each individual part are related to like a big picture. So that is the conceptual diagram. Graphical abstract, this is some journals they recommend or they even require like a graphical abstract, and that would be like a visual summary for your work, and does not need to be a visual summary for everything you did. I mean, it shouldn't, because you cannot do this. That is not the right way of doing it. But it just gives the reader like it's all this is like to improve the reader engagement. Yeah, it's just like will like engage the reader and make him interested in like for example learning more about your work, like reading your abstract or reading the paper. Yeah? And getting the take homes from your paper just by looking at this graphical abstract. Yeah, so we will like so by the end of this video, like all this is just like remember, like why are we doing this again? Because communication, like you have some ideas, and being able to communicate your ideas in writing or through like oral presentation or written communication or visual or visualization or some visual figures. Yeah, so that's all tools we are learning to improve our communication skills. Yeah, so communicating your ideas and make it more clearer to your audience. Yeah, so communicate complex idea using conceptual diagrams. So that you should be able to do this. That's what I want you to learn. And again, this is something you're not going to learn in one video, but like you learn this incrementally and you learn this by doing it. But this video will just give you some ideas and that you can learn on and build on as you advance in your career. Okay. And conceptually design visual abstract to generate reader interest and communicate like your research story. So again, like this is not a graphics graphics course, but so you're not gonna like how to design a visual abstract. Like you can again, we talked about like raster editors, graphics editor, and vector graphic editors. How to use this raster or vector graphic editors, that's like beyond the scope of this course. Like actually, if you want some of these raster graphic editor like Adobe Photoshop, like people would spend like not a course but could spend like a whole like they could spend more than one course just to learn a skill like this. Yeah. But here, what I want you to is just conceptually design, like just from the conceptual point, like what your abstract should or should not include. Just as we did with publication quality figure, we will like do it here. Yeah. Okay, so just let's get started. Yeah. Uh, uh, Conceptual diagram. We always start with like why or the what. Yeah. Like let's start here with both of them. So just like I mentioned this before, so I don't want to repeat myself. You communicate like key message. You don't communicate all message. You communicate key message or one key message, one take home from your paper. That would be like a sorry, that would be for the visual abstract. But for the conceptual diagram, you here we are talking about conceptual diagram, not visual abstract. Sorry, I got confused. Communicate key messages. So like there are key messages that you want to communicate and then you communicate them this through conceptual diagram. Like for example, you want to explain to the reader what is groundwater sustainability. What are groundwater dependent ecosystem? What does this mean and why these are important? What are different levels for uncertainty analysis and different types of uncertainty and different method for accounting for uncertainty and so on. So you communicate like this message through a figure. And I will show you some example for all. I will show you like some examples for this. Uh, then, so that's one way. Like you want to specify like a specific key message, yeah, like uncertainty analysis, groundwater sustainability, groundwater dependent ecosystem. I want to explain. But another thing is that like you want the reader to understand the big picture. So you want the reader to understand your method, like how your different part of your method is connected as a whole. So that's also another thing. A third thing is that like you could be like telling a story. Yeah, you could be telling a story, and that story is not only like. And remember, here we are not talking about conceptual diagrams for your report only or your proposal only, but we are also talking about conceptual diagram for your presentation because you use these conceptual diagrams. There are some conceptual diagrams that can you use in post presentation and report, and there are some conceptual diagrams that you can only use in presentation but will not be very meaningful in report, or others that would be meaningful in presentation but not in report. Yeah, so you use this to tell a story. So like you can have a diagram and then for your presentation you stand there and use this diagram to tell a story. Yeah. Or you can tell a story in your report. Yeah, and that would be different. And I will try to show you examples. Like depending on the time, like we I don't like to keep this video very long, but we will see. Yeah. Okay. uh, So how communicating complex idea using a figure, like how do you do it? Yeah. How can you communicate complex idea using a figure? So now here is the rule. Yeah, this is the rule of thumb. This is the rule of thumb. A good figure does not cause more confusion. Yeah. So that's the rule of thumb. Like so you look at your figure and you will say, will this figure confuse my reader? Will this figure cause more confusion, or this figure will create more clarity and help the reader to better understand like the stories that I want to tell them or the message that I want to deliver. And then there is a rule for this. It's called like KISS. So KISS means, that's the rule, keep it simple, stupid. Okay, I mean, I don't know why it's this, uh, but that's the main message. Yeah, like I think like the one who came up with this rule, like he said, like if you didn't keep it simple, that would be stupid. Yeah, it's not you who are stupid, but that's like not smart thing to do. Like the smart thing to do is just to keep it simple. The stupid thing to do is that you make some complex figures that will create confusion and no one will know what you're talking about. Yeah. And again, is this something easy to do? No. I mean, some people are talented, some people are not. Am I talented in this? I don't know. Maybe not. But some people are very talented in this. But that's the rule. Like, that's what you try to achieve. Yeah. Whether you can achieve this or not, that's like a different story. Yeah. But that is the rule. Like, keep it simple. Okay. So here is just like making a conceptual diagram. Uh, so again, like how can you make it simple? Like first, you if the idea is not clear to you, it's not going to be clear to the audience. Similarly, like if you are a teacher teaching something and you don't understand very well what you're talking about, you will not going to be able to deliver this understanding to the student. Similarly, if your message is not super clear to you and it's very vivid in your mind, like what you want to deliver, yeah, then it's not going to be obviously not going to be clear to the audience. Yeah, because you generally expect the audience not to like you the one who know about this more than your audience. Yeah, because that's your work. So sometimes your audience might know more because they could be like have more experience in this or more in, or they're smart audience, but typically like you should know more about your work than anyone else. Anyway, so the first thing is like you want to be clear. What do you want to present? It should be clear to you. And then after you know what you want to present, the second question is to ask you, what is the simplest way that I can present this. And the simplest is minimal, like the minimal way I can present this. The minimal graphics that I can use, the minimal font change or font colors that I can use to present this. Yeah. So here is like because you don't want to use like 10 different colors that doesn't add any new value to here. Yeah. So like you see, look at this slide design, for example. It is very minimal. Yeah. I only use two different color. I could use this to be black. The reason that I'm using this to be orange, for example, is that orange will uh, will attract your attention more. Do I need this orange color? Probably not, but it will attract your attention more and will make you more interested. And that's why like you will choose like an orange. I don't want it to be red because red that would be might be too scary. Orange will just like stimulate you, but will will not be distracting. But is it needed? Probably not. Yeah, I could just like if I want to make this simple, like this slide simple, that could be black and that could be black and just could be simple. Yeah. But anyways, this is not a diagram here. This is all text, yeah. But we're talking about diagrams, yeah. But I'm just talking about like the simplicity of your design, yeah. So no need to add like any additional shapes or something like this if they are not and then use the simplest shape to build your diagram. So like if you can build your diagram with the simplest shape, like simple vector shape, you don't probably wouldn't need like an Adobe Illustrator, like Adobe Photoshop, like a raster editor or anything like that. You just build like the simplest shapes, the minimal, like usually minimal things that makes like a good graphics. That's in my opinion. Some people could have like different opinions, but anyway, let's just look at an example. Yeah. Conceptual diagram. So I told you why do we do conceptual diagram? Conceptual diagram, we show like a big picture. So here I'm showing like the big picture for my method, yeah, like a method that I have, yeah. And so this is a class exercise I want you on Canvas to. So I will talk about this figure. I will explain it and put my own evaluate it uh, so evaluate it, and then I want you also to do the same. Yeah, don't agree with me. You don't have to agree with me. We don't need to agree with one another. You know, that's one thing for sure. You know, that's like life is diverse, and we don't need to agree on everything. Yeah, we can agree on certain things. We can disagree on other things, but we don't obviously need to agree on everything. So then take my word. Yeah, I want you to put your opinion. Yeah, and your evaluation. So evaluate this conceptual diagram giving these two criteria. A good figure does not cause more confusion. So does this figure confuse you more? And keep it simple. Yeah. Otherwise, that will be stupid. Yeah. Okay. And yeah. And of course, don't call like your instructor stupid or anyone stupid, yeah, because again, this is another thing we I want you to learn for in this course is like how you can professionally disagree with someone, yeah. And by the way, I've seen this when I like reviewing papers. So for example, like I will like be a reviewer. I will give like a reviewer comment, and then I will find the author starting like to take it personal or to start to get angry or start to say, "Oh, like you don't understand. You know, like they won't say you're stupid, but things like that. Yeah, that's not nice. Yeah, because any disagreement it should be done in a professional manner, and that's the skills that I want you to learn. Like so, for example, like sometimes I submit my work to be reviewed, and then I get like reviewer feedback, and then when I get this review feedback, I it's clear from me that like the reviewer didn't understand like this like the point I want to make, and that's why he does not like it because he didn't understand or she didn't understand. So how could I communicate this to the reviewer in a respectable in a respectable way? Should I tell him, oh, you don't understand? I mean, or you don't have enough knowledge or you don't know about this topic? No, I don't do this. First, I go to my writing and I see, is my writing confusing? That's maybe why, because he doesn't understand. That doesn't mean because he lacks knowledge. It could be because of my mistake, because my writing is confusing. My writing is not clear. So I go to my writing and I say, maybe, okay, maybe I need to clarify this a little bit. Maybe I need to clarify this a little bit. Or maybe this part is not clear and I need to improve this part. That's how uh, so that's the first that would be the first step from my side. Like you should first like look what mistake you did before you go on and disagree with someone. And if you did some mistakes, then you try to correct it. And after you correct your mistakes, then how do I address this review or comment? I will tell him it seems like if my text was unclear, then I will tell him, oh, it seems that my text was unclear and that caused like a confusion or misunderstanding. I clarified my text and showed this and this and this, and then I explained to him what I think he does not understand. The issue is resolved. Like you see how I was able to resolve the issue in a respectful and professional manner versus I go and tell him, oh, you don't understand this, you don't have this knowledge, you need to learn this, blah 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 blah. Yeah. So that is also a skill that I want you like to learn. That's what, by the way, this if you go check your course syllabus, this is one of the learning objective of this course. Yeah, it's one of the learning objective of this course is that we don't need to agree with one another. That's life. I mean, there's no such thing in life that everyone agree on everything. But when we disagree, we need to disagree in a professional manner, and we need to disagree in a constructive way. Where in a constructive way, which means like will add value to me, like it helped me to improve my work, and it add value also to the reviewer. It will help him to understand like something new that he didn't know, or help him to create his confusion or her confusion. So this is clear. Yeah. Okay. So okay. And some people will also not like it. Like if somebody, some people, like if you call them like, oh, you're stupid or you don't understand, they might like have some bad feeling about it, and you don't want to do this also. Yeah. And some people, they, I mean, they don't care, but okay. Okay, so anyway, this was, sorry for this like detour from uh, our lesson today, but I think this is like an important like detour because this is one of the learning objective of this class, and I'm not sure if I got the chance to talk about this before or not. But anyway, let's focus on our lesson. Let's get back to our lesson. Enough side discussions, yeah. But this is what I want you to do. Like I want you like to provide your evaluation regardless of what I will my evaluation or my what I'm showing here. So here in this thing, like what I'm trying to do, I'm just trying. So these are like there are like people go to emergency department for respiratory illnesses, and these would be like the different factors that will cause those people to go to this respiratory illness. So this is called like the dependent variable, and these are called like independent variable. Okay, so this variable depend on these guys, but these guys does not depend on they are just independent. Like tourism, for example, they are, or temperature, for example, like these are independent. Yeah, but if temperature increase or decrease, that could increase or decrease the number of ED visits. If tourism increase, of course, that will increase the number of ED visit because like you have more people, so you have more people and more people will go to use like healthcare system and other services that are available. Influenza, pollen, and so on. Like if pollen increases, ED visit will increase. So this is called the dependent variables. This is a dependent variable. So basically, so what do I want to do here? I want to predict ED visits based on like these variable. And how do I do this? I do this with like a statistical exposure response model. So basically this model like will tell you, okay, like when this guy increase, for example, then this guy will increase. Like when this guy increase, for example, this guy will increase. When pollen increase, for example, this guy will increase. So that's what this model will tell you. Okay. Uh, and now, so I take this data. So this is my independent variable. This is my dependent variable. This is my independent variable, and I try to parameterize this model and calibrate it, like make sure. So I have ed visit already, like historic data, and then I will try to reproduce like this historic data giving this factor. So basically it's called like I train my model. Yeah. So I will train my model based on historic data so that it will be accurate. Yeah. And then what do I want to use this model for? I want to use this model to project this in the future, to project like respiratory illnesses in the future. And if I want to do this, then this means that I need to replace my historic data with future data and scenario. Yeah. So with red tide, for example, I have like three future scenario. With pollen, I have two future scenario under like this is called CMIP scenario. Like this is for like climate change scenarios that are used like worldwide, yeah, scenarios by different country. Like this is a assessment report, like every 10 year we do like an assessment report, so this assessment report will be based on these scenarios. Yeah, so I have like these two temperature scenario. Influenza, I will just use like a trend scenario, so I have only one scenario. Tourism, I historic data, like historic trend, I will just project this to the future. So how many scenario do we have? So we have two climate scenario, like this s like 4.5 and 8.5, and we have like three red tide scenario, like low, medium, and high. So that will bring a total, like if you multiplied this one by this one, so this is 2 times 3, that will give you 6 scenarios that we want to evaluate. And so this sixth scenario will be evaluated with this model. So now here, this is my parameterized model. I will evaluate this sixth scenario, and that would be the model output. So what will I get? What will I get from this? Monthly hindcast and projection of ED visit giving historic and scenario data respectively. So basically, I will hindcast like this, like projecting back, and projections. This is projecting forward of the ED visit, giving like this historic data, like giving this historic data, and this like scenario, future data. So this is historic data, and this is like future data. Monthly impact of each independent variable of the total number of ED visit. I will see like, so like, let's say this is the total number of ED visit. I want to see this is due to like red tides. This is due to pollen. Yeah, and maybe the rest is due to temperature, and maybe small amount is only due to like these two guys. Yeah, so I want to see the contribution of each one. Yeah, impact of each independent variable to the total number of, and joint impact of independent and dependent variable to the total number of back. Like I want to see also not just like the individual contribution, but the joint impact. So for example, under this climate scenario, we only have this much ED visit, but under other climate scenario, like high emission scenarios, then I will get more ED visit. I will have more people visiting ER due to these things. Yeah. So I want also to see like the individual impact and the joint impact. So that's the figures that I showed, like so that after the reader read my method and understand, like again, remember, I'm just this figure, I'm summarizing my method. So this figure is not like standalone figure. Like the reader will read my method. After he read my method, you look at this figure and he say, okay, now I know what this guy want to do. So what basically this guy want to do? He want to get like this historic data, train a model, then he will have a trained model. And after he trains this model, he will replace the historic data with future data and will project this into the future. And then when he projects this in the future, he will see, for example, how red tide will increase ED visit and how ED visit will emergency ED visit will increase in general. Yeah, that's the idea of this conceptual diagram. Does it cause more confusion? In my opinion, it doesn't, especially if you read the message. So you read the message and you read this, then it should give you like a clear message. Is it a simple figure? I don't know. I don't know. I don't know if it's this simple figure, but if it can be more simplified than this, just let me know. Yeah, let me know if this is just like figure is too much, too dense, too condensed, or and it could be like a little bit more simple than that. Yeah, that's something I generally like struggle with myself, and that's something that I'm always trying to improve. Like, how could I make whatever I'm doing much more simple? Because simple things is generally better. Like, and it's if you can understand if you understand something well, you can explain it in a simple terms. Yeah. So that is basically something I'm also trying to improve is how to do things more simple. Yeah. Okay, now another way, so I also want you to do this class exercise, like repeat the same thing. This is like we want to communicate key messages. So another way we do this conceptual diagram is to communicate key messages. So in this research, let me just explain to you what this research is doing. So this research we're trying to make an engineering design, yeah? And in this engineering design, we have like a model for an aquifer. So let's say this is a model from an aquifer, and in this model, and let's say I have one conceptual model because the aquifer is in the subsurface. Subsurface is uncertain. I don't know this. So I have one conceptual model, a second conceptual model, and a third conceptual model. And then I want to create like an engineering design. Yeah. This engineering design will tell me, for example, like how much water I need to pump, like where should I put my pumping well, and by how much I need to pump. Like let's say I want to put my pumping well here and one here and maybe one here. The circle size show you how much pumping, how much water I'm pumping. So if the big circle is big water, small circle like less water, yeah, something like this, yeah. So so I run my optimization, yeah, for this model, for this simulation model, then I got this answer. Then I have another conceptual model for the same site, yeah, because I have different conceptualization. I'm uncertain about the subsurface. So let's say my other design, it was something like this. I got like this answer, like this pumping well here, this pumping well here, this pumping well here. So yeah. And then let's say I have a third conceptual model. So that's the same conceptual model for the same site. And then let's say I got like one here and maybe one here and maybe one here. Now, in reality, I only have one reality. So which solution am I going to implement? Like, am I going to implement like this designs that tell me like this three location, or this designs that tell me this three location with this pumping rate, or this designs that tell me this three location with this pumping rate? Which one I'm going to implement? Because I have three conceptual models, because this is my uncertainty, three different conceptualization for my site. But I need to implement only one solution in reality, yeah? I need to go dig three well and specify certain pumping rate for this three well. So which one am I going to do? Like, so this is the problem. This is my research problem. So here, how could we like so that's conceptual diagram describe how you can deal with this problem. So one way is independent model run, just as I did here. So this is one, like this is my model one, this is my model two, this is my model three. So I run my design here, I find this design here, I run my optimization here, I find this design here, I run my optimization here, I find this design here. So this is my concept. So I run my optimization on this conceptual model. I get a design. I get a design here. I get a design here. And this doesn't need to be three. It could be any number of model. And then you analyze the result. Yeah. So I got an optimal design here. I got an optimal design here. I got an optimal design here. And then I analyze my result. I said, oh, okay, maybe this is might be like this model calibrated better, so I might go with this result. Or maybe like, see, these two results are similar, this one, like this design is a little bit different, so maybe I will take this one and this one because these two look similar. So I analyze my results. So we call this independent model run. Another way is like we call it like cross-validating optimal design. What does this mean? It means I have a model, I run my design, I run my simulation optimization, I get a design. So I run my simulation optimization on my model, I get a design. I run my simulation optimization on my second model, I get a design, so on and so forth. And then the optimal design of this simulation of this like of this model, I cross-validate it on the other model. So basically, I will take this design and run it on this model. I will take this design and run it on this model and see how it will perform. And then like the design that will work on all the model and will satisfy all the models, that would be like the optimal design. Yeah. So that's like another way to do this. So I presented this idea here. The third way to solve this problem is that like I have these three model, I can find an average model. Like, so there are statistical method where you can use, like if you have three model, you get one model that like could represent like these three models, something like this. It's called model averaging. So basically I have conceptual model one, conceptual model two, conceptual model three. I average them into one model and then I run my simulation optimization on this one model and then I get an optimal design. So that's another way to solve this problem. The fourth way to solve this problem is what? You have your different model, Why don't you run your simulation optimization on all of them and find one design that will satisfy all these models? And we call this concurring ensemble member. So I have like different model. I run the simulation optimization. I try to find the solutions that will satisfy all these models. So it's just one solution, yeah? And then I get one optimal design, yeah? So this is the conceptual figure that I created to communicate like these messages. So like if you have this problem, if you have like multiple model, but you only have one reality, and multiple model will give you multiple, could give you multiple design. See, multiple model could give you multiple design, as in this case, or multiple model, you can average them. If you average them, they will only give you one design, or multiple model. If you just run your simulation optimization and all of them find one solution for them, then will give you only one design. So these are the complex ideas that I wanted to communicate by preparing this figure. So communicating like some key messages, yeah. And you can go like check this paper, like if you want to learn more about this. I don't know if this is an, yeah, you can check this paper and basically like you see I like if you go to this paper here, I have like this conceptual diagram and then I explain it and then I put example from literature. So you see here, these are example from literature saying like so this guy, for example, like he used this method. See, this guy, for example, he used this method, like here, this method, like the model averaging method. This guy, for like this study, for example, like what are we presenting? We are presenting like this method and this method, like here, the COVOD and the CEM. Yeah. So you even like provide a figure, then you provide a table, like some example from literature, and that will make the reviewer life easy and the reviewer be happy because now they understand what you want to do. And then then now see, I this is figure one. That's my first figure, a conceptual diagram to explain. Then now if you go later here, you'll see all these equations that when the reader go and read all these equations here, they will know what does this equation present because now they have this conceptual understanding. Yeah. Okay. So that is another example for this. Yeah. So that's like so here I showed you like shows a big picture, communicate like key messages. Conceptual diagram, it tells a story. You could also like tell a story. So this is like an encyclopedia article that was mainly written for education purpose. So Elsevier, they have like an educational module. They like to write like these articles that could be used for like if you want to learn about like what is groundwater sustainability. Yeah. So you just go whether you are a student, whether you are a researcher, and you want to learn about this topic, then you go to this module that's called like reference module. This is a reference module in earth system and environmental sciences. So you go to this reference module, and this reference module has many books in it, like this book, for example, where this paper was published, or this what was called like Imperial, the Encyclopedia of Conservation. Yeah. And then you get this educational paper. So I'm doing an educational paper to educate like researcher and like mainly graduate and maybe upper undergraduate students. So that conclude should have like less text and more conceptual diagram, because that conceptual diagram makes big picture. So I think like we can go like we can you can have it like you can provided the link for it here. So let's see, this is our first conceptual diagram. Like it's about like groundwater sustainability, and it's telling you the 8 essential factors considered when evaluating groundwater sustainability at local, regional, or transboundary scale. So basically, like this is what it tells you, that you have an this is your groundwater stock. You have aquifer performance factor, and then you have an aquifer governance factor. Aquifer performance factors like your natural groundwater system, and the infrastructure like the pumping, injections, the conjunctive use, the managed recharge, like your infrastructure, yeah, for desalination treatment and so on. And then you have also, and then like the natural aquifers, these are the different factors that consider this. Yeah. And then you can read about it again. Then the aquifer, but it's not only aquifer, it's not only then like aquifer performance. You also need to consider aquifer governance. So aquifer performance has like natural groundwater system and infrastructure system. Aquifer governance, this has institutional system like legal and institutional constraint and socio-economic system like societal value and preference and economic feasibility. Again, this course is not about groundwater, but I just want you to appreciate, like if you are a groundwater student, if you are interested in this topic, when you see like something like this and this conceptual diagram, how this will help you to understand a lot about this topic. Now, let's see another one. Here, this groundwater sustainability evaluation framework with uncertain scientific knowledge encompassing natural and societal science and participation of groundwater governance framework. So here, a groundwater sustainability evaluation framework. So here, if I want to evaluate groundwater sustainability, like in a certain area, what do I need? So you need, like see here, you need to account for three things. You need to account for our scientific knowledge, you need to characterize the system, you need to understand about the management, and you need to acknowledge your uncertainty. But you need to do this in a democratic process, so multi-stakeholder and multi-level participation. And this dialogue between you and your stakeholders, you will learn from them and you will improve your scientific knowledge and you will make your science more direct towards their need. Yeah. And then you also need to, your scientific knowledge and this participation need to be conducted within the groundwater governance and infrastructure systems that is existing. So again, this course is not about this, but like if you are interested in this, you can pause the video and look at this, and then you will see like how these three parts are connected, how scientific knowledge, participation, you need to do this in a democratic process, and you need to observe the existing governance and infrastructure system. Yeah. Let's look here. Let's look at this guy. uh, Groundwater dependent ecosystem. So if you want, like these are different groundwater dependent, like GDE, groundwater dependent ecosystem. So now if you want to know what are groundwater dependent ecosystem, these are wet forests, these are buffer strips, these are lakes, these are wetlands, these are peatlands, these are stream, riparian zone, hyporheic zone, uh, estuary, coastal lagoons, caves, the aquifer itself it's a groundwater dependent ecosystem. Yeah. Marine environment. Yeah. Now, groundwater important. Why groundwater is important for these aquifer systems? uh, uh, See, it maintain water level, pressure, and fluxes. So it maintain, like for example, see here, like the wet forest, this is your groundwater table. This forests are tapping through the groundwater table. If this groundwater table went down, what will happen? You This forest will not be longer green. It will be, that's when you see like this yellow forest, then you would suspect, okay, this yellow forest because my groundwater level went down. And is this explained? Yes, this is explained here. But here I'm just explaining why they are important, because they maintain water level, pressure, and fluxes, and because biogeochemical conditions, they control like temperature, oxygen, organic matter, dissolvent iron, and nutrients. Yeah. So see how I'm telling the story here? And now I'm showing you like the impact of pumping. Like once I start pumping, what impact will occur? So like let's say number one, increase in drawdown, like water level will go down. So pherophytes, these are like these types of plants that are tapped to groundwater table, will no longer be able to reach water table. So you see here, I'm just like each number here, and then you see like the impact of pumping on this like specific ecosystem. And then somebody will tell me, what do you mean by ecosystem services? What an ecosystem services is? So there are four ecosystem services, and here I'm showing you what are these four ecosystem services, like provisioning service, regulating service, culture service, and supporting service. So you see how like I'm telling a complete story. Like you don't, like this is a topic that's new to you. You don't know it. You just see this figure. You learn about it. You read some text, and then you will get a story. You will get like a story, and you will learn something. Yeah. How did I prepare this figure? So this figure was a combination of raster. This is like a raster image, but it also has some vector elements in it. So for this figure, I think like see all these shapes are like vectors, uh, vector elements, but it also has some raster elements. I think like see this caves and these are also like some raster elements. See this colors here, these are some raster elements that I added, but all this is a raster figure. How did I prepare this figure? I prepare this figure with PowerPoints, yeah. And if you are interested, I can share, like, if you are interested, let me know on Canvas. Tell me, please share with me the PowerPoint templates that you use to prepare this figure, and I will share it with you. Yeah. Okay, what are others? See here, uncertainty analysis. So here, nature of uncertainty. It could be aleatory, like random errors. It could be epistemic, lack of knowledge, or it could be an ambiguity, contradicting societal preferences. So that's also source of uncertainty. Like you have different societal preferences. Sometimes they are agreements, sometimes they are contradicting. They are conflict of interest. So these are the nature of my uncertainty. Literally, like just some random errors, like any measurement will have a random error. Or epistemic, lack of knowledge. Like I have a subsurface, it could be this, it could be that, I don't know. Or it could be ambiguity. What are my sources of uncertainty? It could be contextual, like natural, technological, economic, social, and political. It could be input, like my input data to my model and the driving forces. It could be water ecological human model, like model structure, like the model itself could be uncertain, like the model structure, the technical detail of the model parameter, and the model output could be also uncertain. Yeah. So these are the sources of uncertainty. What are the level of uncertainty? And so here, this is like a statistical uncertainty. All possible outcomes are known, all probabilities are known. Scenario uncertainty, all possible or some possible outcomes are known, no probability. Qualitative uncertainty, some outcomes are known, some probability are known. Recognized ignorance, no outcomes known, and we don't know. So that's the level of my uncertainty, like how uncertain I am. That's like less certain here, very uncertain. Yeah. And for each of these ones, there are different methods to account for this. Like it's no one method to account for all these. And you see here, like if you want to have, if you have context uncertainty with the statistical uncertainty, then you account for this one, actor analysis, and this uncertainty method, and then I provide a short description. Again, I'm telling a big story here about like how to analyze uncertainty analysis. So again, so these are some attempts I have done before to create like this conceptual diagrams to tell a story. Yeah. How successful I am or not, I mean, you can let me know on the discussion board on Canvas. Yeah. Okay. But this is just like example of conceptual layer. How we are doing in time? We are doing good in timing. Still have plenty of time. So let me start like a new topic, and I will end this module with this new topic, which is like a visual abstract. So some journals they require like a visual abstract, like like for example like science here for the total environment. So that would require like visual abstract. Uh, Let's see any newly accepted paper. Yeah, whatever. Uh, see, it require like see this is a newly accepted paper. I'm just selecting multi-dimension risk assessment and source analysis of micro and nano plastic in dairy cattle's farm and inner Mongolia case study. So you see, this is the highlight of the paper. This is the abstract of the paper, and then after the abstract of the paper, you see here like a visual abstract. Okay. I mean, is this a good visual abstract? Yes or no? So this basically some of the results. This is their methods, and I don't know what this is. Yeah, but they require it. Yeah. So, but let's learn what is like a visual abstract and why to have like a visual abstract and also so the what, why, and how. Also, yeah. And how to make like a good visual abstract. Yeah. So what is a visual abstract? This is like a concluding figure from your article, like a take home message. That's how I generally like to see it, as like to do it. Other people might do it differently. Yeah. Some people like as the examples that we just saw in a minute, I think they're just providing an overall summary. That's okay, but could be also like a concluding figure. Like I generally would put like the take home message there. Yeah, or yeah, see, a concluding figure or a figure capturing the content of an article in a single glass. So concluding figure like one take-home message or the main take-home message, or it could be capture like your main, like your introduction, your method, and so on and so forth. Why visual abstract? Why could it be helpful? Sometimes you just do it as a requirement, but sometimes you do it because it's helpful. So it helps the reader to quickly gain an overview of your work and understand your take-home message. So that's basically how I do them. I just want to visually, the reader to visually see and understand what I'm doing. Yeah. Uh, uh, and then, of course, to generate reader interest in your work, because sometimes, like when you see this visual abstract will resonate with you, then you want to read this paper. Uh, How to make a good visual abstract? Again, keep it simple. It should be concise. It should look nice, and it should be a good visual summary. And by good, not by pictorial or it looks nice doesn't mean that you should have complex diagrams or complex images or anything like this. Sometimes simple thing looks nice, or even look nicer. Yeah. So just make it concise and simple. Yeah. So that's like how to make like a good visual abstract. So and I will tell you, like, as we go on, I will tell you some of, like, give you like specific tips as we go on. But before we I give you like I start giving you specific tips on how to make a good visual abstract, before we do this, I will, again, as we always do, I will just try to show you a few examples. So this is an example: visual abstract concluding figure from the paper. So this is the conclusion of my paper. So this paper, I was like, it's a review paper about, like, if you want to evaluate groundwater sustainability, what components do you need to include in your analysis? So groundwater sustainability, let's say like you are a groundwater manager and somebody tell you evaluate the groundwater sustainability for this aquifer or for this region or for this state. Yeah. What your analysis, what are the main components that should be present in your analysis, in your evaluation? Yeah. So groundwater sustainability evaluation with the sphere number reflecting increases degree of integration. So the first thing you will like, let's say your supervisor told you evaluate the groundwater sustainability of this aquifer. Then what would be the first obvious thing you will tell him? What do you mean by groundwater sustainability? Do you mean like safe yield? Yeah. Oops. Do you mean like safe yield? Do you mean like sustainable yield? Do you need sustainable groundwater development or sustainable groundwater management? Because if you want to go from here to here to here, then more components need to be included. Yeah. So that's the first question. Like, then he will tell you, okay, I want to maybe like sustainable yield, or I want this one. Yeah, I want to do this one, or whatever. Yeah. What are the main components that you should include in your analysis? So usually, like for groundwater, we use modeling a lot because these are natural system, and we bring this system on our computer and we study and analyze them on our computer. Yeah? So it should include like multi-process modeling, and this modeling would be like the summary of our knowledge of what we know about like this system. We present our knowledge in the form of a model. Yeah. But what else should we include? Another thing we should include, like when we develop this model should be developed based on participation. So that could be like a top-down, like technocratic thing. Like I'm just a modeler. I come and I do my thing, and then I give it to people, and I tell them, okay, this is a good model. I don't know what you can do with it. Or I can build this model and integrate all this knowledge based on participation with my key stakeholder. So I involve my key stakeholder in this modeling process and building this model, and not only involves them, incorporate their knowledge and their experience in this model. So, so if you want to be sustainable, your modeling process needs to be based on participation. Yeah. But what else? Uncertainty analysis. We should be humble. We should acknowledge our ignorance. We should clearly state this is what we know. This is what we are uncertain about, and this is what we don't know. So we need to have this epistemic humbleness. Yeah. So these would be like, so you need to present your knowledge. You need to be humble when you present your knowledge, and you need to do this in a democratic process. That's basically the three main components. Now, I want safe yield. So if I want safe yield, just safe yield, then I will present my surface water groundwater system in the modeling process. I will have like statistical and conceptual uncertainty when I include my uncertainty. I will have demand-driven research. Demand-driven research, I will see like, okay, this is something that the community is interested in. I will do it for them. Yeah. But if I want to increase the level of integration, as it says here, like go to here to like a sustainable yield or sustainable groundwater development, then I need not only to account for the surface water groundwater system, I need also to account groundwater dependent ecosystem. For participation, I need to do collaborative modeling, like build this model with my stakeholder. And I need to not just do some statistical uncertainty, but do scenario uncertainty and adaptive management. Adaptive management because this groundwater dependent ecosystem could be highly uncertain. Yeah. Now I want to even go even better. Then I need to account for human activities. Like how are we using this water? Are we using this water, for example, for sugar cane farming? Is this the best use of this water? Because sugar cane farming, this is water hungry crop. Yeah. Or water thirsty crop, not a hungry crop. Water thirsty crop. Maybe I will replace this with organic farming. That could generate more revenue and improve even the water quality and reduce stress on my aquifer. So I need to include human activity. I need to like do peering and social learning. Just do a lot of social learning. Learn about like, okay, what is this sugar cane industry, and can we replace it with organic farming, for example? And then I need to do gaming and ambiguity, like this level of uncertainty, because I told you there are different societal preferences and they could be contradicting. So here I just provided like a summary for like what this paper, like this is a 50-page paper. Like when I wrote this was a 100-page like a Word file, and it was a 50-page paper like when it got published. This is a summary of this 50-page. Now when the reader sees this as a visual abstract, then if they like this, then they can go to the paper and learn about these details. Yeah. Okay. Let's look at another example, and I think this is the last thing that I have here for this lesson. Visual abstract, a figure capturing the content of the proposal. So here I'm capturing the content, like here I'm just summarizing, concluding the paper. Here I'm capturing the content of the proposal. So I have a method, I have an output, and I have an impact. Yeah. So here I am showing my method, like I'm saying, okay, this is my dependent variable, emergency department visit over respiratory illnesses. This is my dependent variable, environmental crisis like red tide, environmental factor, pollen and temperature, respiratory disease, influenza, interannual population change like tourism. So I will input all these guys to a statistical model. The output would be what? So here's the output of this scenario. Total number of ED visit. So I will get like how many total number of ED visit. Impact and joint impact of an independent variable, like uh, of the independent variable, sorry, like this independent variable on the total number of ED visits. And then I show it here. This is the output. And so here, like this is the historic condition, number of emergency department visits. So from tourism, we got this number. From influenza, we got this number. From temperature, we got this number. From pollen, we got this number. From red tide, we got this number. But under future climate scenario, like this scenario and this scenario, so this is like a medium emission scenario. This is a high emission scenario. We are expecting not only like see like I have this number of red tide, I'm expecting them to increase, but we are expecting ED visit to increase in general. Yeah. So here's a hypothesis: respiratory illnesses increase with climate change. That's our hypothesis. See. So now you look at this, you understand the method, you look at this, you know now the output, and then somebody will tell you, okay, so what? I mean, okay, fine. I mean, respiratory illnesses will increase with climate change. What do you want to tell us? Now, I'm here because this is a proposal, yeah? Remember, this was a proposal. This is not a paper. So now, before the reader read my proposal, I want to tell him why this is important, yeah? So intellectual merit, like why this is important, it's an intellectual merit. This is a novel environmental data science method. So this method, like when you bring all these components together and you're able to estimate like the contribution of each and the joint contribution. This is a novel method, like a method that will help science, yeah, method to study respiratory illness from red tide and environmental factor in changing climates. We are providing a novel method. Okay, I mean, this will advance science. So what? Why this is important? Well, show the importance of greenhouse gas reduction to improve public health related to respiratory illness and reduce economic impact. So here I'm clearly showing like with climate change, we're going to have more of this. What does this mean? This could encourage people to reduce less greenhouse gases and uh, and improve public health related respiratory to improve like the public health impact of climate change. But somebody will tell you, you know what? Yeah, people know this. People know that climate change is bad and it will have bad impact. Okay, we know this. I mean, and no, they're not going to reduce any greenhouse gas production. We will just continue business as usual. Fine. If you don't want to mitigate, you can adapt. So you see here, climate change adaptation. Support decision about expanding the capacity of respiratory service. Now, people might start to be interested here because sometimes people don't want to change what they want to do. So we'll just keep doing what they want to do. We will be in a trouble and then we will adapt to this trouble. So here I'm explaining how this could help you to adapt in this trouble. And then climate communication. Raise awareness about climate change and respiratory illness to advance science informed, equitable public policy. So this is like also climate communication. So I'm showing here the impact. You cannot understand, like, see, all, like you need to read all this to understand like this big image. But here, this is what I want to show you. The conceptual figure, it needs to have a text with it to explain what this respiratory illness due to environmental factors such as red tide, pollen, and temperature are expected to increase under CMIP scenario for moderate emission, like here, and high emission. Then so that is the first misconception about like this visual abstract is that like visual abstract are standalone. They don't need to be accompanied with text. No, visual abstracts need to be accompanied with text. So this is the first misconception about visual abstract is that they does not need accompanied with text. No, because for example like you are not expert like in climate change, so you don't know what does this like 4.5 or 8.5 mean. So here I need to explain this to you like moderate emission and high emission. Yeah, and I'm explaining to you the main message of this figure. So that is the first misconception about like visual abstract. A second misconception about like a visual abstract is that all data need to be visualized. No, you don't need to visualize like all your data. Actually, too much information could overwhelm the reader. Like, are these the only impact of this research? If you check the proposals, there could be more. Yeah, but I just selected here the four that might like, okay, so this is scientific advancements, this is the intellectual merit, this is the broader impact like mitigation, adaptation, and then communication. I just selected, strategically selected like intellectual merit and three broader impact, mitigation, adaptation, and communication. Yeah, so not all information need to be, just prioritize one or two major finding or major insight, yeah, that are most significant. Here I prioritize it like, here it has a lot like, so this is one thing, respiratory illness will increase with climate change, and I emphasize it like two key points that I emphasize like intellectual merit, and then three and like broader impacts, mitigation, adaptation, and communication. Yeah. Uh, Visual, third misconception I talk about this, like visual can replace text entirely. No, you need text. Uh, like reality is like a well-designed visual abstract need concise and supporting text to ensure clarity. So that's the reality. So a solution, like so, if you like, so the solution is like add like a brief like targeted label and to explain the like the insights or what is the take home message that you want the reader to know here. So that would be part of the image. Yeah. Now another misconception is that aesthetic design equal effective communication. Like I have a beautiful looking figure, this means that this is an effective communication. No, graphics, if the graphics look attractive, that doesn't mean that your message will be clear. Yeah, visual appear will not guarantee effective communication. Yeah, so ensure effective communication, match the design with your message, even if you can sacrifice some of this aesthetic flair. Yeah, so if you will satisfy if the so sacrifice aesthetic flair, but match the design with match ensures the design match the design matches with 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 your message. Yeah. So this is another aesthetic design equal effective communication. Yeah. So that is another uh, color always enhance your understanding. No, do not use colors unnecessarily. So only use color if you want like see here I'm using color like environmental crisis red tide, like environmental factor like pollen and temperature. That should have like see here is a mistake. That should have a green color to be like consistent with the green color here. So you see I do mistake. Like now I figured out this mistake. Yeah. Respiratory disease that should have like this color here, and this is like this color here. So basically I'm matching this. So that might help comprehension, but like don't if color will not add any new information, don't use them. Yeah. Every component of the study must be represented. That's also another misconception. Like trying to capture everything will make the abstract like cluttered and hard to follow. So uh, distill like the study into like single like storyline and key message, and just make your abstract like focus on this. Yeah. Visual abstract are like for expert only. This is another misconception. Yeah, effective visual abstract can abstract can engage like broad audience, and that would be like an effective abstract. Like you see here, maybe the broad audience will not understand this, but they will understand this and they will understand this. So but so visual abstract are not for experts. They could be also for broad audience. Another misconception: static design are sufficient for digital platform. Actually, no. Like this is a static design, but if you have like a GIF or like an animation, that could even improve understanding. So if you have an animation, that could also use it to improve understanding. If it will add new meaning, if it will not add new meanings, then don't use it. Yeah. Uh, Graphic would be understand without a context. No, you need to provide context. So you see here, I provided context here, I provided context here, and I'm providing context here and here and here. I could just pay like intellectual merit and put in an image here, mitigation and put an image here, but I'm providing context. Yeah. All like last misconception is that all visual abstract follows the same template. Uh, No, there is no one best way to design the visual abstract for all your study, and each study, like see, this visual abstracts follow a very different template than this visual abstract. So they don't need to follow the same template, but tailor the visual abstract to the content and the audience, ensuring that it conveys the message effectively. So, in summary, avoiding this misconception can help you to create like a clear, engaging, and effective visual abstract. The key is simplicity, relevance, and alignment between the design and the message to ensure that your visual abstract serves as a gateway for the audience, your audience, to understand your work. So let me do this here. Like if you want to read more about this, let's see here. If you want to read more about this, so I have, I mean, like you can pause the video, and so these are like the 10 different like misconception about like a visual abstract and how you could fix them out. Yeah, so you can just like more graphics means better communications. That's a misconception. All data need to be visualized. That's a misconception. Visual can replace text entirely. This is a misconception. Aesthetic design equal effective communication. This is a misconception. Colors always enhance understanding. This is a misconception. Every component of the study must be represented. This is a misconception. Visual abstract are for expert only. This is a misconception. Static design are sufficient for a digital platform. That's a misconception. Uh, the graphic will be understood without context. That's a misconception. All visual abstract follows the same templates. That's a misconception. Yeah. So you can just pause the video and read through this. Yeah. So you can read through this. You can pause the video here and read through this. And let me change back to here. And you'll find this in the text. Like if you get downloaded your slide, these are all in the notes of the slide. Okay, so if you want to read more about this, I have put some figure here. This is the site that I was trying to open. Uh, it was like it has a high traffic, it couldn't work. Yeah, that's okay. Still, it seems that still has a high traffic. But if you want to learn more about like these topic, like these are some links that I suggested, and I think that's all for this lesson. And then see you in the